So we're going to continue solving systems of linear equations. These are two different sets of linear equations, and like we said before, solving a system means we're going to try to find their intersection. I don't need to graph these. I can look at this pretty quickly and see that the slopes aren't the same, so there's going to be an intersection. Anyhow, we're going to look at this problem first. Our job here is to add and subtract one equation from another, add or subtract one equation from another, such that one of the variables goes away. Sometimes this is really nice. Imagine if there was a 4 right here, right? And there isn't in this case, but imagine there was a 4. Well, I could add these two equations together, and the negative 4x and the 4x would eliminate each other, and then I could just keep adding down the line and come up with an answer. That's not how this one works. So this is a slightly more complicated one than what you're going to start with. So what I do is I look and I go, if I multiply this bottom equation by 4 all the way through, I could rewrite the bottom equation and say that's going to be 4x minus 12y, right? I'm just distributing this 4, equals negative 24. That shouldn't be too bad. So now what I need to do is I can ignore this line here. All I've done is just multiply that by 4. It's the same equation. So now what I can do is I can look at this top equation and this bottom equation and go, if I add them together, negative 4x plus 4x, well, that's 0x. I don't really even need to write it down. 9y minus 12y is minus 3y. 9 minus 24 is negative 15. So this 0x, we can ignore that because anything times 0 is 0. And then I just need to divide both sides by negative 3, and I end up with y equals 5. I am not done yet because I need to go back and find out what x is, so I can take this 5 and I can plug it into any one of these three equations. This one here that I've crossed out looks the easiest, so I'm going to say x minus 3 times negative 5 equals negative 6. Right, I'm just copying from here. And I get positive 15, so x plus 15 equals negative 6. We subtract x equals negative 21. So my point is negative 21, 5. Yeah, negative 21, 5. Okay. So, yeah, that's that one. Slightly more challenging is a problem like this. And this one's more challenging because there's no easy number that I can multiply this by or that by to cause elimination to happen. So I'm going to just choose to multiply this, the top one, by 3 and the bottom one by 5. And it's kind of like finding a common denominator. Because I know 3 times 5 is 15 and 5 times 3 is 15. So I know that I'm going to end up with a 15x and a 15x, so that's going to be good. So I'm going to rewrite these expressions. So I'm going to distribute this 3 all the way through. 15x plus 12y equals negative 90. Don't forget to always multiply the last one as well. So that's the top. Now I'm going to do the same thing with this line. 15x minus 45y is 5 times 18 is negative 90 again. Yeah, that's right. Now, I can subtract the top one from the bottom one because 15x minus 15x is 0x. 12y minus negative 45y is plus 57y. Equals negative 90 minus negative 90 is 0. Divide both sides by 57, I end up that y is 0. Again, I'm not done. I need to go back and find x, and it looks to me like this one would be my easiest equation, so this is what I'm going to use. 3x minus 9 times 0 equals negative 18, Anytime 0 goes away, divide both sides by 3, I get x is -6. So I know the point -6, 0 is where these lines intersect. Thank you.